This is Lecture 7 in the FOA series on premises cabling. In this lecture, we'll discuss testing UTP cabling. There are numerous tests that can be made on an installed UTP cable plant. Some of them are quite obvious, like wire mapping to make sure the connections are correct, and the length of the cable to make sure it's within the specified length of the standard. Then there's a whole bunch of performance type specifications that require specialized testing. There's also a number of testers that are used to make these tests. So we'll look at the testers and the tests to make sure that you understand them all. There are three basic types of copper testers used on UTP cables in premises cabling. A wire mapper tests for correct connections, something that every installer should do as soon as they finish making a connection. There's network verifiers, a new type of tool that tests for operation with a specific network, for example, Ethernet. These testers will also usually do wire mapping in addition to their network testing. Then there's what we call a certification tester, which tests for compliance with standards like TIA 568 or ISO IEC 1101. These are the testers that most people think of when they think of testing UTP cabling. Wire mapping is simply testing to make sure that all the wires are connected to the proper pins. If you don't get it correct, there are some common faults. For example, terminating one end as T568A and the other is T568B, so you get pairs 2 and 3 crossed. Or terminate a pair on a jack with the 1, 2, 3, 4 connection scheme that's used for punch-down blocks, and you get split pairs. Most certification testers and verification testers, as well as all wire mappers, will do a wire map as the first test in a test sequence. The next test is to verify the UTP cable length. In a link, or the permanently installed cable, it must be less than 90 meters, or about 300 feet. The channel, which includes the link plus patch cords, must be less than 100 meters. You can test this with a TDR, or time domain reflectometer, which is a tool included in all certification testers, as well as being available as a standalone tester. Certification of the installed cable, what's called the permanent link, has to be done according to industry standards, and the standards are different for each category of cable. The permanent link includes all of the installed cable and is typically done from the jack at the patch panel to a jack at a work area outlet. The tester includes special patch cords calibrated with a reference plug, and they tested all the frequencies required for each category. The attenuation of the cable plant is tested as the tester sweeps through the frequencies over which the cable is specified to run, according to its category rating. Attenuation is higher at higher frequencies, so the testers test at multiple frequencies to see if the cable plant meets the industry standards at all of the frequencies specified. Crosstalk refers to the coupling from an active pair transmitting signals to another pair in the cable. It's typically tested as next on the near end and fexed on the far end, because it's mainly at the connections where crosstalk is a problem. Power sum crosstalk, which has been required for all cables since Category 5, refers to the coupling of signals from 3 pairs to the other pair. It's necessary because these cables now transmit signals in all 4 pairs at once. It's important at all the jacks and plugs and punchdowns to maintain the twists as close as possible, because that's where most crosstalk occurs. With Category 6A cable, there's another problem, and that's alien crosstalk, going from cable to cable. Return loss is a reflected signal caused by an impedance mismatch. The impedance mismatch is usually caused by improperly making connectors, generally leaving too much wires untwisted, or kinks in the cable. Mismatched components can also create problems, which is another reason you want to make sure that all components are of the same category grade, and at the highest category grades, perhaps even from the same manufacturer. Delay skew is an important test for cables used for transmitting gigabit Ethernet or faster. And the reason is that these systems use all 4 pairs, transmitting a fourth of the data on each of the pairs. So it's important that they arrive within a specific time frame so they can be reassembled into one signal. The reason that the time period may be different is the different pairs have different twist rates, and a pair with more twist actually has more length of copper. So this is another test that certifying testers always test for. More information on testing UTP cables can be found on the FOA website at the online reference guide. Go to www.thefoa.org.